Here we go. So today we're going to talk about scatter plots. I'd like you all to turn to page 186, please, if you're not there already. So right there on the top of 186, you'll see the word scatter plot highlighted in yellow. Y'all see that? A scatter plot is a graph that shows the relationship between two data sets, between time and money, or age and value, or amount of water you put into something and how high it is, how high it's grown. Whatever these two things are, X and Y, okay? The two data sets are graphed as ordered pairs in a coordinate plane, and scatter plots can show trends in the data. So sometimes they can show trends. So I want you to look at the top page 187. There's three scatter plots there, right? The one on the left, do you see the positive correlation? It seems that as X increases, Y increases, right? Okay. The next one, negative correlation. We've done this already, haven't we? Yeah. As X increases, Y decreases. And then the one on the right, we have no correlation. It's just kind of randomness. There's nothing we can do about it, okay? So what we want to see, or what we like to see, is some type of correlation between the X and the Y number. We want to see a correlation between how many hours we work and how much money we make, so that we can make predictions about what's going to happen out in the future. Well, what if I work this many hours? What if I work this many hours? Let's look at the one I wanted to talk about right away. Example 2. Right below that, there's two graphs: age and vehicles owned. See the age and vehicles owned, guys? So it looks like, is there any real correlation between, hey, if you're older, you have more vehicles, or if you're older, you have less vehicles? No, there's no real correlation there, is there? So we can't make any guess about, well, if you're 60, you'll have this many, or if you're 50, you'll have this many. There's just no correlation between those two things. But look at the next graph over. Temperature and coat sales.
Negative correlation.
Yeah. The colder it gets, the more cold. I mean, when it's dang cold, people buy more coats. Okay? I mean, that's just the way it is. So there is a correlation between those two things. And you can see, yeah, you guys already said it's negative correlation. And I want you to look very carefully at graph B, and I want you to notice on the x-axis there's 0, and the line comes over and there's like this little heartbeat thingy, and then it goes straight to 35. You guys understand what's happening right there?
No, I don't.
Anybody? Yeah, we're skipping. We're skipping the graph. We're just leaving from 0 to 35 basically out of the graph. I don't know why they're doing that in this case. Maybe they live somewhere where it just never really gets colder than 35 degrees.
It's either 0 or 35 and up.
Yeah, I mean, are there a lot of places where it just doesn't really get much lower than 0 or 35? Yeah. Now here, where we live, that's not really a thing, right? It definitely gets colder. Okay. You have to be a little bit careful, though, when you see graphs with a skip in them like that, because we can make them say what we want them to say, or I can make you think what I want you to think, by kind of adjusting how we do things. Whenever you look at a graph, regardless of what type it is, you want to look for that kind of thing in there, because if one graph is solid, it might look like this. the same exact information can be put on a graph where we can skip a bit of it, and we can make the graph look like this, or maybe like this, okay? By cramming these together, okay, one way or the other, we can make the graph look steeper, or we can make it look less steep, okay? Now, why would we want to do that?
I don't think you do want to do that, do we?
Well, what if I'm trying to get elected and I can say, so here's the graph if we leave the X and the Y alone, right? Well, here's the graph. If I kind of cut a bit out of the X, I can make the graph look like that. What if I'm running for office and I want to say that the guy that's got the job now is doing a terrible job, and look, our extra jobs in our community aren't really going up much at all, right? And everyone looks at the graph and goes, yeah, look at that, they're pretty much stagnant, nothing's really happening. Well, does that match what's maybe really happening? And if I'm the other guy, I take a chunk out of this graph and I make the data look like this. Ooh, wait a minute. We're kicking butt.
Yeah.
We got jobs like crazy coming in. Can you see both of them doing that? Does that actually happen? Yes, it does. Number of COVID deaths, number of people with COVID. When you look at the graphs and things, you have to remember, when you look at a newspaper or a news article or something like that, they're trying to sell the news. Okay? If the COVID deaths basically looks like this, just slightly going up, is that going to get everybody all riled up and want them to read the news and buy newspapers and look at the online news? Is that going to happen? No. No, it's not at all. But look, if we take a chunk out of here, instead of going 1, 2, 3, 4, 5, if we just skip on up to 100, okay, we can make that graph look like that. The same exact data, we can make it look a lot different, can't we? Okay, and we're going to do some of this too, so you'll see exactly how it works. But you need to remember, whenever you see a graph in the newspaper, online, whatever it is, you need to look for that. Okay, and if they have a skip in the data, you need to think about, why do they have that? Why is that there?
So today's lesson is to cheat on how to make yourself look better.
Sometimes we just want to focus on this part of the graph, and that's what's really interesting. Sometimes we want people to think the way we want to think, okay? Or communicate a great big lie. And I know you're freshmen, but I think you can handle this. There's a guy named Mark Twain. You guys ever heard of Mark Twain? If you haven't, then you need to read a book. He said something about statistics, and graphs and things like this are statistics. And he said, there's lies, there's damn lies, and then there's statistics. Well, what did he mean by that? He meant that we can take information and we can skew it to make it look how we want it to look. Okay, and that's something you need to be aware of. And we're going to look at some graphs out of the newspapers and things and have you make some, and you're going to say, oh yeah, I can see how that could be done. Now, I'm going to show you something. You don't have this on your graph. See my line there? What do we call that line? You remember? Line of? You've done it on Alex, haven't you?
Line of fit.
Yeah, line of fit. Sometimes we call it the line of best fit. Okay? And it's not the line of perfect fit, right?
Right.
It's kind of like an average, right? I just drew the best line I could through this data, tried to hit the middle of all the data as well as I could, and then I came up with an equation for it. Why would I want to come up with an equation for it? so that I can put any number I want in for x and see what y would be. Yeah, I can make a prediction about what's going to happen out in the future, maybe. Okay. Average daily temperatures. These only go up to 70 also, don't they? Okay. But we'll look at some different things. But I'm coming up with the equation of this line. And I'm just going to tell you a couple of secrets to making a line a fit. Number one secret is, look where it hits the y-axis. Does it just hit the y-axis any old place? I was kind of, if I can, I try to hit that y-axis at a nice pretty number. And I use that point to make my line. And then what else do I need? If I've got 1 point, what else do I need? A slope. What if I get another point? Can I get a slope? Yeah. Okay. So we can choose a couple of points. Maybe this one down here. That one up there, 0, 70, and 70, 10. With those 2 points, we can find a slope, and then we can find the equation of the line. And then, heck, if I wanted to say, well, what if the temperature is 0 degrees? Could we put that number in this equation? You guys are supposed to answer that part. Sure. From this graph, I could say, well, what if the temperature's down here at 0? What if it's up here at 90 or whatever? Although it looks like once you get up to about 80, are you selling any coats? No.
But that's when it's like cheaper though. That's the best time to buy coat.
You know what? That might be that's pretty good point. Okay. Down at the bottom of the page, you will see some information, some data, and what we want to do is make a graph here. So temperature in Fahrenheit, that's X. Attendees in thousands, that's Y. I don't know, maybe this is for a baseball game or something like that, right? The temperature. Do you think if it's an outside activity, the temperature might have some kind of effect on how many people attend the event? I think so. Okay. So what we want to do is make a scatter plot of this information. So the first thing I want you to do is look through that plot right there. Are there any negative numbers there?
Nope.
X's are all positive, Y's are all positive. What does that tell us? Yeah, it's the first quadrant. So that's the first thing I'm going to do is I'm just going to make this. Now you notice I got out a straight edge, didn't I?
Yeah.
Okay. This is X. This is temperature in Fahrenheit degrees. This is number of people attending. Attendees, well, I guess we'll say. So this is our Y. I guess we could call this the T-axis for temperature, and this one the A-axis for attendees or whatever. Doesn't really matter. Okay, so what do we have to have across here for X's? What's our lowest X? 71. Anything lower? 68. Okay. Well, what's the highest X? 68 and 92. All right. Well, I guess here's a question then. Do I want to start here with 0 and go 10, 20, 30, 40, 50, 60, 70, 80, 90, 100?
No,
Or do I want to make a little skip and just go from maybe 60 to 100? Do you see how we can do it either way?
Yeah.
Okay. Well, we're really not concerned with anything below 68, are we? So let's go ahead, make a skip, and we'll just call that 60, 70, 80, 90, and 100 degrees. Okay? All right, what about attendees in thousands? Oh, I didn't put that. In thousands. What's the lowest number?
Where are you seeing?
Number 3, 1.7 thousand. And what's the highest number? 5,500. So we have 1,700, that's the lowest, and 5,500, that's the highest. So what do we want to make our scale go from? Do we want to go from 0 to 6,000? Do you want to skip a ways? And this is pretty low. Let's just go from 0 to 6,000. Now, I don't know if there's a right answer here, guys. Okay, yeah, you understand what I'm saying? So I'm just going to say, like that. You okay with that? And then what are we going to do? We're going to graph these points. Now it's hard for me. I don't have any lines on my graph here. So you're just going to have to tell me a little bit, but let's go. 82, 4.5. Close?
Yeah.
78, 4.
Bingo.
6.8, 68 degrees, 1.7,
Yeah, I love it.
87 degrees, 5.5, 75 degrees, 3.8, 71 degrees, 2.9, 92 degrees, 4.7, and then 84 degrees, 5.3. That good enough? Okay. Do you guys see a correlation here? Okay, does it look like positive correlation?
Yeah.
It does. So, I am a little worried though. I'm a little worried that if the temperature gets up much above here, that attendance might drop off. What do you guys think?
It might.
It might.
Information.
Okay, it might. But in this area, I think we've got it. And we can draw a line of fit here, can't we? Something like, now everyone's line of fit's going to be a little different, but I'm going to go like that. Okay? Now, I don't know. What do you guys think about this line of fit, though? Is it realistic? Do you think when we get up to 100 degrees that we're going to have 7,000 fans? Who thinks that? Who wants to go to a baseball game when it's 100 degrees outside? Two of you. Okay. So, what about down here? 55 degrees, do you think we're going to have 0 fans show up? No. So this line, it might really only be true kind of in that area right there. So you have to keep that in mind. But there's the data. We made a nice graph. We made a scatter plot. We see the positive correlation. We drew a line of fit.
I don't really feel like that's an accurate graph for a baseball game. I feel like it'd be like peaking at like 80.
Do ya?
Like 85, 75.
Well, it went down right here, didn't it?
Yeah. So
It kind of 85. It did kind of peak, and then when we got up to 90 something, 92, it went down a little bit, didn't it?
Yeah.
Okay. So this is one of the problems with real life. Real life doesn't fit nice, simple little mathematical models all the time. Sometimes we have to think about it a little bit more. Right, Lilith? Basin, you with me, buddy? Okay. Okay, let's go over the page. Example 3. The table shows the weekly sales of DVDs and the number of weeks since its release. What is that talking about, the week since its release? Yeah, how long it's been out on DVD. What do you guys think happens when a movie first comes out on DVD,
Everybody's like negative.
and then after a while everyone's seen it, and so, I mean, nowadays, does it even come out on DVD? I mean, I don't even know the last time I got a DVD. It comes out on Netflix or it comes out, but it's kind of the same idea, right? It's released some other way other than just at the box office. Okay, write an equation that models the DVD sales as a function of the number of weeks since its release. Interpret the slope and the y-intercepts of the line of fit. So they give the information here. sells in millions of dollars, weeks since release. So 1 week, 19 million. Get out to 8 weeks, we're down to 5 million. Can you all see the graph?
Yeah, that's going.
Definitely negative correlation,
Yeah.
right? You all see the line of fit. If you drew the line of fit, would you draw yours exactly in that same place? Yeah, probably not. Okay, probably not. Everyone's going to draw that just a little bit differently and come up with an equation that might be just slightly different, but generally we're good. We do use computers to help us with this. We can take a calculator like this and we can put those data points, XY data points, in the calculator and ask it to calculate a line of fit, and it'll come up with the one that fits it the best. But we're just practicing right now, so we're just kind of looking. So what do we need in order to draw or to find the equation of a line, guys? Point and a slope. And if that fails, at least what's the minimum we got to have? 2 points. There you go. So you see the 2 points they use. 5, 10, and 6, 8. Okay, I'm going to tell you right now, whoever wrote this book and did that, those guys are idiots. Why would I choose 2 points that are super close together? Is that going to give me the best accurate line?
No.
What gives us a more accurate line?
Like 1 is very hard.
Okay, so tell me a point that's
1 and 19.
okay.
-5.
I'd even go further left.
Really?
Think lazier. 0. Why wouldn't we use 0, 20? That's the y-intercept.
Wait, how do we know there's 0, 20?
Well, it might not be exactly 0, 20, but you have to understand, we're not coming up with the equation of exact fit. We're coming up with the equation of best fit, right? So we don't have to be exact. But if it looks like it goes through 0, 20, and that's the y-intercept, why wouldn't we choose that point?
I don't know.
Yeah. Okay. Okay, now pick a point way out on the other end. 10, 0? Whoa.
You mean 0, 10.
No, it's 10, 0.
Oh, dang it.
Yeah, it's 10, 0.
Yeah, X first. That's my bad.
Okay. Well, heck, with those 2 points, can we come up with a slope?
Yeah.
Sure. 20 subtract 0 over 0 subtract 10. That's 20 over negative 10, which is negative 2. Well, we see a negative correlation, right? Do we already know the y-intercept? Yeah, it's 20. So y equals negative 2x plus 20. We don't even have to do point slope form or anything, do we? Okay? But here's the hard part now. In the context of this problem, what's this 20? I mean, what's the 20, guys?
No.
Yeah, what's happening when the DVD first is released?
There's 20 million.
Okay, right. 20 million is what it starts out at. But even that first week, it kind of goes down, doesn't it?
Yeah.
Okay, and then what's this negative 2 per week? What's happening to the amount of money it's making every
It's
week?
dropping to 2 million.
It's going down 2 million a week, right?
Yeah.
So in the context of this problem, that's what we're talking about here. Okay, I think maybe we should use time and weeks and money. What do you think? Now, I don't know if that's the equation. I guess that is the equation they came up with too, isn't it? They did. But I don't know. I'm lazy. If I can choose 2 points on my line of fit, one of them is going to be the y-intercept.
Yeah.
I mean, that's just flat out. Why wouldn't you choose that point, right? I mean, it's your line. You're writing the equation. Go for it, right? Might as well make life easy. Okay. Jim, you ready to do some work? Well,
Get ready.
that is actually what I expected you to say. Chapter 4.4. Will you do it anyway, Jim?
Yes, I will.
Okay. 2 through 18, the even. 22. 25 through 28. It's not that bad. Use a straight edge. Make your graphs neat. Make sure they have labels and everything. Be careful. I'm going to grade this a lot on how it looks.
Oh boy.